Good day, everyone. So our topic for today is circuit introduction. What's today's lesson? Circuit introduction. And today's aim is for you to understand the concept of a circuit diagram and how to interpret them. Okay, so objective of today's lesson is for you to know what the definition of a circuit, the electrical terms in a circuit, and how to identify and describe the basic component of a circuit. So, describing a circuit, in the first place, what do we mean by the word circuit? Now, an electric circuit is a path through which electric current flows. Any path through which electric current flows, that's what we call circuit. Okay, that's what we call circuit. So, it can also be defined as a loop of wire with its end connected to an energy source. Now, you charging your system, charging your phone, yes, they are all circuits, okay? Because it's the fundamental concept in understanding how electricity works, okay? So, any path in which electric current flow is what we call a circuit. So, how does a circuit look like? Now, like a diagram. Let's update. So, this is what we call a circuit. Now, here, this is what we call a battery. Battery has two cells. If you have we have what we call cell, that's single cell. That's not a battery, but when we have double cell, then we have a battery. And remember, this is it. This is how it looks like. Okay, this is the battery, and this is a lamp. So this is how the diagram of a circuit looks like. Okay, and this is a battery, and this is two lamps. So this is how the diagram looks like. So we have something like this. So this is a symbol that represents lamp. Okay. That is the symbol that represents lamp. And this is a symbol that represents cell. Okay. And cells. Okay. So now we have different symbols here in a circuit. Now, let's have all these in one circuit. I want to explain how we can have all these in one circuit. Now, I told you this is a battery and this is a cell. So we have a battery here. Okay. Now here we have a battery. This is ammeter. Ammeter is used to measure the current flow in a circuit. This is voltmeter. Voltmeter is used to represent the voltage flowing in a circuit. Okay. And this is a resistor. A resistor opposes the current flow in a circuit. And we have a lamp. This is to represent a lamp. And this is a motor M. Okay. Now, actually, I just want to use all these symbols to have them in one circuit. Now, this is a resistor, this is a lamp, this is a motor, voltage, ammeter, this is switch. Okay. When we switch off, this is how it looks like. When we switch off, that means there is a current that needs to flow in, but this current is not flowing in because we switch it off. But when we switch it on, then the current will flow in all the circuits. Okay, this is what we call a battery, right? A battery here is the power source of this circuit. Okay, so that's the diagram to represent some variable in a circuit. So now what is current? If we say a circuit is the path in which current flows. Now, what is current itself? Now, current is the flow of electrons. Current is the flow of electrons. So this depends on the push given by the battery. And what is that push given by the battery? The push is what we call voltage. Current is the flow of electron in the circuit, while the push or the source of this electron, how the force out this current is what we call voltage. So components in the circuit provide opposition to the current. So there's all the components in the circuit, they provide opposition to this flow of current. And why do they do that? It's because they have what we call resistance. So resistance is the opposite of flow of current. The opposite of flow of current, that is resistance. So when the battery is connected, the electron in all parts of the wires within the circuit move at the same time. So in the same direction and the same rate when we switch on in the circuit. So this movement consisted the current in this way. No matter where the components are in the circuit, they all have the current at the same time. So now let me explain voltage, current, and resistance, and a circuit itself using this analogy. Now just think of it. We have a stream, right? A stream or a river. Now, the part in which this water flow is what we call circuit. Okay, the part in which this water flows is what we call circuit. The water itself is what we call current. Okay, that's the flow of electron. So the water itself is what we call current. Now, there might be some rocks or there are some other things that is disturb this water to flow very well, and that is what we call resistance. Okay, the parts in which this water flow is what we call circuit. That's why we say circuit is the part in which electric current flows. What is electric current? That's the water itself. And if there is anything disturbing this water, is what we call resistance. I hope you understand that. Now we can use another analogy to explain voltage, resistance, and current. Now think of it. You having a straw, okay? Having a straw. So the air flowing through this straw is what we call current. That's the air flowing through the straw. But your own force pushing this air is what we call voltage, while the straw itself is what we call circuit. Do you understand now? So circuit is the part in which electric current flows. Voltage is the push or the power that allows this current to flow. Okay, while resistance is another power that's trying to resist, that's trying to limit the flow of this current. So that is voltage, current, and resistance. Okay, so in our next class, then we go with Ohm's law that represents all these three variables. Okay, so that will be the end of today's class. And please, thank you for watching. Don't forget to click on the subscribe button. Bye.